Good morning, Algebra 2 Trig students. Today we are going to be working on our notes for Trig Day 7. Start by doing this warm-up. Press pause, and when you're ready for the answer, press play again. Here are the answers to the warm-up. The process is just like it's always been. We've got to find the reference angle first, and then after we find that, we find the angles for the solutions in the quadrants with that reference angle. So to find the reference angle, I do inverse cosine in my calculator, making sure I'm in degree mode because I'm solving in degrees, and to get my reference angle. I find that it is 89 degrees rounded to nearest degree. I would always tell you where to round. In this case, I rounded to the just 0 decimals. And then I know I'm going to have solutions where cosine's positive. Cosine is the x coordinate, so cosine is going to be positive on the right side. So I have an answer in quadrants 1 and 4. So the next thing to do is draw the angles in those quadrants. I have again in quadrant 1 and 4, both with a reference angle of 89 degrees. In the first quadrant, it's quite easy, it's 89 degrees. In the fourth quadrant, it will be 360 minus 89 degrees, or 271. Cosecant, same process, but you have to be careful. Switch cosecant to be sine. I know that the reciprocal of cosecant is sine. So sine of theta would be 1 over 2.6131. And then I can use inverse sine to find the reference angle here. So my reference angle is 22.5. Then I have to decide where I'm going to have my solutions, which quadrants. And cosecant's positive and also sine's positive, the reciprocals of each other. So I know that it's going to be in the quadrants where y is positive, since sine is y and cosecant's 1 over y. So it's in quadrants 1 and 2. The first angle is easy. It is the reference angle. And the second angle is 180 minus the reference angle, 157.5. The last question in the warm-up, it gives me that I would like to find 5 trig functions where tangent of theta is negative 12 over 5 and sine is greater than 0. So tangent's negative. That means it's in quadrants 2 or 4, and sine is positive. So that makes it in quadrant 2. So I draw my reference triangle here, and I know that tangent is y over x. So my y is 12, and my x is negative 5. X is negative in quadrant 2, 12 is positive. Using Pythagorean theorem, I find my radius is 13. Remember, we're not in the unit circle. So now I know what x, y, and r are, so I can find my other trig function values. Remember, cotangent is x over y, or adjacent over hypotenuse, adjacent over opposite, negative 5/12. Cosine is adjacent over hypotenuse, or x over r, negative 5 over 13. Sine is opposite over hypotenuse. Opposite, 12 is my y, 13 is my r, hypotenuse. Cosecant's the reciprocal of that. Secant is the reciprocal of cosine. I want to take a minute with you on how to find angles in the various quadrants when you know the reference angles. So in quadrant 1, it's easy. Again, your angle is equal to the reference angle. But if I were looking in quadrant 2, remember that I want to find that angle with the reference angle. Let's call our angles theta. let's make this theta. In my first quadrant, my angle theta is equal to the reference angle. In the second quadrant, it would be pi minus the reference angle. Remember that your reference angle is the angle formed by the terminal side of your angle. It's an acute angle, positive, here with the x-axis. So to this spot would be pi minus the reference angle. Remember, we're in radians. If I was in the third quadrant, it would be pi plus the reference angle. And in the fourth quadrant, if my reference angle's there, my angle would be 2 pi minus my reference angle. On the right, you will see that I have the pi approximated, giving you an idea about the decimal values. But quite honestly, I wouldn't even worry about this. I would worry about this because you would plug it into your calculator and round at the end. I'm going to solve a couple of these with you. Then I'm going to have you press pause, try the rest, and then we'll check your answers. So let's do together number 1 and number 3. Okay, let's take a look at number 1. I'm told that sine of t is equal to 0.0456. Now, again, what we have to do is find our reference angle, find the quadrants, and then find the angles with those reference angles in the quadrants we'd like. So first, I'm going to work on finding the reference angle. It's inverse sine of 0.0456. So in your calculator, make sure your calculator is in radian mode, then press second and then the sine button for inverse sine of 0.0456. That returns 0.04, let's round to 3 decimals, 0.046. That's my reference angle. Looking at number 1, I see that sine is positive. Sine is y on my unit circle. That means my answers are going to be above the x-axis in quadrants 1 and 2. So now I have my reference angle and I have the quadrants. I'm going to draw my angles. I've got my first angle in quadrant 1 and my second angle in quadrant 2, both with that reference angle, 0.046. And in quadrant 1, it's easy. It's just simply the reference angle. In quadrant 2, it will be pi minus the reference angle. And we'd use our calculator. So you access pi in your calculator. Second pi minus 0.046. And that will give you 3.096. 2 answers right there. And that does the problem because I only want answers between 0 and 2 pi. Next, let's take a look at number 3. Again, the same process. We're going to find the reference angle, find the quadrants, then find the angles for my solutions in those quadrants. So to find the reference angle, I first want to rewrite secant in terms of cosine. I remember cosine's the reciprocal of secant, so that means that cosine of t is equal to 1 over negative 1.046. Now to find my reference angle, I do inverse cosine of that positive ratio because that will return for me my angle in the first quadrant, which is where my reference angle is found. So in your calculator, again, make sure your calculator is in radian mode. We're solving this in radians between 0 and 2 pi. And you press second cosine of 1 divided by 1.0456. So now I know my reference angle is 0.296, rounded to 3 decimal places. That is in radians. The next thing I need to do is decide which quadrants I have solutions. So secant is negative, cosine's negative, so my answers are going to be where x is negative to the left of the y-axis. So I'm going to have an answer in quadrant 2 and also in 3. To find those, I'm going to draw them. So I have one here and one here, both with the same reference angle. So the first one is going to be pi minus 0.296. And the second one is going to be pi plus 0.296. So again, using your calculator, the first one is going to be 2.845, and the next one will be pi plus my reference angle, and that's 3.438. So 2 answers to that problem. The next thing that you should do is press pause on your video and do the rest of the problems on this page. Let me show you which ones I'm talking about. Do number 2 and number 4. Press pause. When you're ready for the answer, press play again. Here are my answers to number 2 and number 4. Again, the process is the same. You find your reference angle. Inverse tangent of that ratio gives you the reference angle, 0.9285. Tangent's positive, so I determine which quadrants my solutions will be in. Quadrant 1 and 3, where both x and y have the same sign. I have one answer in the first quadrant. That one's the easy one. Right here, that's my angle. My second angle is in quadrant 3, which is pi plus 0.9285, 4.0701. For the fourth one, to find the reference angle, I do inverse cosine, but notice I'm using the positive angle here so that I get my reference angle out, 0.4871. Cosine is negative, so cosine's negative anywhere x is negative. So to the left of the y-axis in quadrants 2 and 3, then I draw my angles, and I find the angles in those quadrants with those reference angles. So the first one is pi minus 0.4871, which is 2.655, and the next one is pi plus, and I did not write the plus there, give me a minute, pi plus 0.4871, which is 3.6287. So now I want you to practice the assignment I put online. Have a great day.